All right, so we're going to be talking about common logarithms this time, this lesson. We've talked about logarithms. You know that logarithms have their bases, right? A logarithm is just an exponent. So I can have, for example, log base 2 of 7, meaning 2 to the power of what is 7? And because logs are just powers, they're exponents, the base could be any number, right? Because you could have any number raised to an exponent. Now, so often in math, we see something times 10 to the power of a number, right? 10 to the power of 4, 10 to the power of 7, 3.2 times 10 to the power of negative 3. How often do we see all that? Very often. So when the base is a 10, we call that a common logarithm, okay? So logarithms of base 10 are called common logarithms, and in fact, they're so common that we don't even need to write the 10. Just like if I were to write x to the power of 1, I don't say x to the power of 1 like this, right? I just say x. Similarly, if I wanted to write log base 10 of x, the 10 is so common that I could just skip the 10 and I could just write log of x, okay? So when you see log of a number, just assume that the base is 10. All right, so let's all take out our calculators and we want to plug these in. So first it's log of 6, right? Now, your calculator already has a base of 10. So when you're going to plug in log base 10, you don't need to type anything in. You just say log of 6, answer, right? Enter. And with logarithms, we always go to the 4th decimal place. So this is 0.7782. So do it again, just log and 6. It's okay. The next one is log of 0.35, 0.35, and that's negative 0.4559. Okay? And even though you cannot have log of a negative number, you can never have, for example, log of negative 9, right? The answer to the log, which is the exponent, can be negative, right? Where we're totally fine with negative exponents, right? Okay, so one place where we use this, there are lots of places where logs are used. We talked about pH, right? That was one place. Another place is sound intensity. So decibels is a measure of loudness of sound and is represented by this formula. Okay, now what is all this? So L is how many decibels the sound is at. Okay, I is what we call sound intensity. That's the strength of the sound. M is the minimum intensity a sound should have in order for it to be audible by the human ear. So in order for the human ear to even hear it, what is the minimum level of intensity? That is M, okay? So what is the sound intensity here? So we're looking for sound intensity, which is I, of a jet engine whose loudness is 125 decibels, so that's L, if M equals 1. So let's see. The formula is L equals 10 log I over M. So L is 125 is equal to 10 log, what's I? That's what we need to find, over M, which is just 1. Okay? So basically I have 10 log I is equal to 125. All right, so how am I going to solve this? What am I going to do? How do I get rid of the 10? Divide by 10, divide by 10. So I get 12.5 is equal to log I. Now, this is an equation. I only have the logarithm on one side. How do I solve this one? What do I do to solve it? Definition of logarithms, right? What's the base of this log? The base is 10. The exponent is 12.5. So I is 10 to the power of 12.5. All right, and let's see how much that is. Let's plug that in the calculator and let's see how much that is. 10 to the power of 12.5. This is 3.16 times 10 to the power of 12, right? So this is in scientific notation. E12 means 10 to the power of 12. Okay? Questions? All right. So how do we solve equations? How do we solve exponential equations, logarithmic equations? So basically there's this process we call taking the logarithm of each side. So look at this one. I have 6 to the power of x is equal to 42. My unknown is x, and x is the what in this equation? Is it a base, an exponent? Exponent. It's an exponent. And how do we find exponent? By using what? Logarithms, right? And we find exponents with logarithms. So what I want to do now is I want to take the logarithm of both sides of this. Okay? Now, every logarithm is going to have a base. What's the base of this power here? 6. So my logarithm needs to have base 6. So I say, okay, log base 6, 6 to the x, equals log base 6 of 42. Okay? So because the base was 6, I say log base 6, log base 6. What if this original problem was 3 to the x equals 42? What would I have done? Log base 3, log base 3. So now, what happens to log base 6 and 6? What happens to the left side here? Right? I just get x, and this is log base 6 of 42. Okay? Now, if this is on a part of a test where you have no calculators allowed, it's totally fine to leave your answer like this. And I'm going to show you in a little bit how to do it with a calculator. We'll come back to this. Okay, the next one. What am I going to do? Log base what? Log base 5, log base 5. So log base 5, 5 to the x is equal to log base 5 of 62. So what do I get here? Right. Okay. So let's move on, and then I'm going to come back to this. So here what I have is log base 6, log base 5. I just showed you that, I just told you that in the calculator, the built-in base is 10, right? If we have a base to a logarithm, we're not like ultimately attached to that base. We could change the base to whatever we want it to be. We do that by the change of base formula, okay? So here's how we do the change of base formula. So here I have log base 3 of 11. I want to change the 3 to a base of 10. So what I do is log base 10 of this larger number over log base 10 of the 3. And like magic, they're the same thing. Okay? So let's try with this one. So let's change the base to a base 10. So this is going to be log base 10 of 8 over log base 10 of 6. Okay? The higher number on top, the lower number on the bottom, and that's all. Yeah. Yeah, so this higher number, technically this is an exponent, right? And then if what was that? Oh no, not higher by higher by placement. Sorry. So okay, so it's log of 8, right? It's log of 8. That number always goes on top. The base always goes on the bottom. Sorry. Okay, so let's do this now. So it's going to be log of 10. I'm sorry, log of 8 divided by log of 6. Okay, and we get 1.1606. All right, I'm going to give you half a minute to do part B and then to go up and do A and B of example 3. All right, so half a minute. I'm going to pause this for half a minute and we'll come back. 3.07, 3.0704 is what we get for this one, right? All right, so what about for the other ones? Anybody? Did you guys do the ones up here? Go ahead and plug these in and make sure you get the same answer. So we get 2.086, huh? And 2.56 for which one? Yeah. Right. And then did you get? Exactly. Okay. So that is pretty much all this lesson is about. All right. So this is gonna be due next class, and then we'll move on to more of this lesson.